The presentation will demonstrate how to develop the simulation scheme for the realization of the criterion function. The criterion function is integral time average error. We integrate from 0 to 100 minutes the product between the independent variable and the absolute value of the error. For the implementation of the criterion function, we need one integrator. We must generate the independent variable with clock signal. We must use the block which will calculate the absolute value, and then we must use a dot product block to implement this product. And of course, we shall also use a block which will simulate the error signal. Namely, we will use one block from lookup tables library. And of course, we also need some blocks for observation. Let's open Simulink library window. Let's open new model. And now I will try to find all the blocks which are needed. I will start with the continuous library. Here is the integrator which is needed. Then math operations library. I will use the block for absolute value calculation. Then I need from this library dot product block. Then I will go to sources. I will need the clock block for the generation of independent variable. Then in the things library, I will use the scope block for results observation and the display block. Then from the lookup tables, I will use one-dimensional lookup table. This block will be used for the simulation of the error signal, which is the input signal. As this lookup table block is a generator of a signal, we must use another clock block and connect this clock to the lookup table block. Then I can rearrange the blocks. So this is the error signal. It must be connected with the block which will calculate the absolute value. Then we need dot product block, then integrator, the display block, and we connect these blocks. Then we must define some parameters. For example, for this lookup table, we must define breakpoints. These are actually points of the independent variable. As the integral interval is from 0 to 100, we must select here the points from 0 to 100, and I will select these points 0, 25, 50, 75, 100. So the function will be described with 5 points, and therefore I must define 5 points of the dependent variable. And I will try to use some points on the way that this signal will simulate somehow the error signal, which is characteristic for the control systems. This means the error signal has usually positive and negative parts, but finally it becomes 0 if the control system works properly. So I will select these values 3, 1, -1, 0, 0. Okay. Now I must select the simulation time 100 and hopefully everything is prepared for simulation. I can start the simulation. Let's see the results. So this is the criterion function for this case. So it usually has some transient response and then it obtains the constant value in the steady state, which is in this case, we can see here on the display block 1719. The error signal is presented here inside this block with this curve, but we can use another scope block. I will repeat the simulation. I open this block and this is this simulated error signal. These are the points which were defined. The linear interpolation between these points was used, but we can also use the interpolation of a higher order. I can open this block, I can select algorithm, and I can use interpolation method, and this is cubic spline interpolation. Okay, let's repeat the simulation. Now I can see the error signal, which is somehow more realistic and has the shape which is usually in control systems. In this case, the criterion function has such response, and we can see also the value of criterion function, which is the steady state value, actually 2247. At the end, we can also change the color of blocks for criterion function calculation. We shall use the yellow color.